Hello folks, so welcome back to yet another video. We have seen the installation of R Studio and R before. Now let us look at few basic concepts like variables, data types, and a few math operations as well as math functions. So let us start R Studio. Let me launch R Studio. It could take a while. So yes, we have our studio open here. I've customized it a bit. You can also do it by clicking on tools and navigating to global options tab, and you can then switch to appearance here, and you can change the modern or sky, which a theme you like. So you can switch between these two themes here as for now, and you can also edit a bit of fonts here for better appearance of the code. And I've increased the font size a bit so that we can see clearly what we're doing. I've liked personally this particular background here for the editor, the cobalt one. I'll click on apply and OK. So that's it. You can customize whatever you want there. And I have few tabs here which are helpful, especially the help, which contains all the documentation related to R. So you can basically press Control S, sorry, to save the R script. That I'll just save this as variables one. So especially since we are talking about variables as a main concept today. So what is the difference between writing an R script and writing the code here? So basically this is a console that R has provided with. So this is a default editor that you can use. But R script is something that you can save for a particular task. You can group the code together and you can save it, and whenever you run this script it performs a set of tasks that you require it to, whereas in console you just can output immediate line by line kind of thing. So it's better to prefer writing the code in a script because it is the industry standard that everybody uses. So I prefer going the proper way, so I'm writing all my code in a script. So this is how you can create a new script. You can go to the file, click on new file, and here you can select all kind of things. But for this purpose, we are selecting our script, and I have this tab open here, which is where we are going to write our code. So you can time to time clear all this gibberish by pressing Control L on Windows and Command L on Mac. So this goes just a finger snap. Okay, so the very first thing, what is a variable, especially for non-CS folks? So variable is a container which contains the memory location of a particular information. What this means? So basically you have a container that stores a particular memory location which has the information that you require. So whenever you want to store some information, you store it in a particular memory slot. You instruct the computer to store it, and the computer assigns it to a particular address inside the hardware, and this address indeed gets into a variable, and that is the address that we call whenever we want to fetch the information that we have stored. So that is a variable. For simplicity, you can just think of it as a variable is a container which contains the information, but in reality it is not just the information, it is the address that is stored in a certain memory location that gets stored in a variable. So in R you can declare a variable. So let me first tell what is this hash and what is this line, why is it different from the other lines that I'm going to write now. This anything that starts with a hash in R is a comment. So what is a comment? For any particular code or programs or set of programs or software, you need a proper well documented code. What that means is whenever you write some code, you need to basically have that code in a proper way which is properly instructed, let's say for example you write a variable called container x, and in R you use there are two operators that you use to assign values, which are called assignment operators. So one is less than and a hyphen joined together. This becomes an arrow, and you basically put 5 and L, and you can call this using this. So whenever I assign this, so they just know that a variable, this is called a variable, so a variable is declared and a value of 5 is inside this, but they don't know what this variable intends to do. So that is the reason we write comments. So anything that starts with a hash is called a comment. So we can write here as this is a variable of type integer class. So I'll tell you what an integer class is. So anything which doesn't contain decimal values is a integer class. There are various classes inside of R, which are what are called data types in other programming languages. So you can check this using a class of function which is provided in default in our library. So you can just type your variable value, and this gives you the type of the class of the variable that you've declared, which is an integer. So here you can see a global environment, which is where this kind of mimics the hardware storage that we have. So we have declared a variable named container x, and you have a value of 5, which is an integer class that is stored inside this. So here basically you have a container and the corresponding integer that is stored here. So basically a variable is a container which has some information in it. So we have declared integer class here. Let's modify it a bit and make it 5.5, which is a decimal value. This kind of throws an error. You can see here, I'll run the script. Yes, warning. So integer literal, so this contains a decimal, so it has automatically typecasted this type into a numerical value. Why? Because R doesn't explicitly need any instruction to convert from numeric to integer or integer to numeric. So that is the reason we remove the cell, and now if we run it again, you'll see that it becomes a numeric class. And it is a convention that you don't put anything at the end when you're declaring a numeric class. Numeric class allows not just decimal values but a range of other values as well. So for understanding purpose, we'll use container x for integer, and I'll declare another variable which is of a numeric type. This is a variable of type numeric class. So I'll basically declare a, let's use this equal. Oh yeah, so by the way, you can use either less than or hyphen symbol and equals to, which is commonly used assignment operator across all the programming languages, but in R the convention is to use the less than and hyphen symbol. So I'm going to use that one as we go forward, but just for understanding purposes I'm using equals to operator right now. You can see here I am using a class of function again to check what is the type of this one. As you all can know that you already know that decimal value is of numeric type, which is what we are going to get here. I'm going to clear the screen as we progress, just for understanding better. So this is a variable of type complex class. So what this means, this is a complex number, still a number class, but still the numbers that we have learned, especially in our high school, complex numbers, you can use them, and you have a certain separate class for this one. You can see it's a complex number. So for complex numbers, you can use this particular class, which is complex number. You can assign it by default, and you can later check what the value is. So there is another class called a string. So what is a string class or character? Both are same. So basically you can take, better understanding purposes, you can take container A and let's just see if this works. The class of container A becomes string. You can check here. By the way, the characters are enclosed between two ampersand, sorry, two inverted commas, and you can see here it's a character class or a string class, whatever it is, because this allows both the characters and strings. You can modify it a bit, and you can write a string here and see that it works for both single characters and strings. We got here container A has this one, so you can use both a string and a character. It works both the ways. So whatever it is that you want to write, you can use this particular class. And there is one more class, the last one. There are only 5 classes of data types. Actually, data types are called classes in R, so there are only 5 classes here in R. The last one is a boolean or a logical class. So what you can do here is basically you can assign either true or false, and you can later check that. As you can see here, if I execute this, if I run this, you'll get something called logical. So this works both ways. You can write true or just T or just F, or however that you want. You can either write false or F or true or T. It works both ways. So there are total 5 classes, total of 5 classes in R as discussed above. You can use any of those as per your need. And now we move on to something called as operators. So what are operators? Let us see with a small example, because you just have 4 fundamental operators in any programming language. But in addition to that, we also have some math default functions that I'll show you today. Oh yeah, by the way, so I forgot to mention something. So to output any value, you can use 2 ways to output it. One is that you can directly name a variable, which is, I think, not available in most of the programming languages. But in R, you can simply output a variable by using the variable name. So let's run this. You get 5.5. Okay, I think somewhere it has gone wrong. Okay, so I think we need to rerun this line. I'll also mention why we had to rerun. I'll also tell you why we had to rerun. Okay, so basically you get a 5 here, which is what we have assigned by rerunning this statement. So in R, whatever statements you select, only those statements get executed or run. So it's not a complete execution that R does. You need to run line by line, especially when you're using the R script. So then you can also output this by using another function without just naming the variable, which is using a print function, which is standard. Why? Because you cannot use the default naming convention of you cannot basically output a variable just by naming it inside a loop. So inside a loop, you have to use a print function, and inside that print function, you have to mention the variable name or function name or whatever that you want to output. So that is why we are going to use print by default whenever we are outputting, not just inside loops, also outside loops whenever we need to use a variable or we need to list a value. So you can see here. So these are 2 ways of outputting variable values. I'll also mention that a comment for better understanding or reading purposes. There are 2 ways to learn how to output a variable's value. And what are those? One is using the variable name directly, and the other is using a print function, especially inside loops. But since this is the standard, I'm going to use the print function everywhere, not just inside loops, but everywhere. I'm going to follow this convention. Okay, let's come back to operators. So what are the fundamental operators that we have in every programming language? It's addition, subtraction, multiplication, and division. Let us take var variable a. So let's take 3. Variable b, let's take 2. So for addition, we just add 2 variables, which is var a plus var b. And for subtraction, let's use var a minus var b again, because var a is higher or bigger, whatever you want to call it. For division, var a by var b again. For multiplication, it's var a into var b. Let's execute one by one so we can see the values here. Before we do this, we need to execute these 2 lines, because why? Because there's no var a and var b inside the environment. So first we need to run those, and these get added to the environment, which means 3 got added into variable a, or 2 got added into variable b, which is like 3 is stored inside a location. That particular location's address is stored inside variable a. So now, since we have run these 2 statements, let us go run one by one. Let's add variable a plus variable b, and we get 5. You can see variable a plus variable b. I'll clear the console. And let's now run the subtraction, which is variable a minus variable b. You'll be getting 1 because 3 minus 2 is 1, obviously. And I'll clear the console again, and variable a minus, variable a by variable b divided by b is 1.5. And I'll also clear the console one last time, and then we'll multiply and get 6. So these are the 4 fundamental math operations which are common everywhere, not just in R. But in R it's more simple than in other programming languages, because of the rules that are simply defined in R than complexly, because R is centered around mathematics, not the other way around. So let's now investigate a few other functions, math functions provided here, for finding out the maximum of given numbers or variables. We use something called as max function. Use some max function. Let's see that in action here. I'll just call max of variable a and variable b, and you can see this outputs 3 variable a, which is the big number or large number among these 2 numbers, variable a and variable b. And similarly for just copy this, for finding out minimum of a number, we use something called as min. What this does is basically it finds out the minimum number among the given numbers or variables, just exactly opposite to what maximum does. So it's minimum variable a, variable b. Oh, by the way, you can use a lot of other variables as well here. You can use n number of variables and it still works fine. It outputs 6 here. You can see it outputs 6. So you can use any number of variables here and it still sends the right output. Yes, so you have got 2 here. So this function is used to find the minimum. Since between 3 and 2, 2 is the minimum, you get the 2 here. I'll clear the console. There's one more, for simplicity I'll define one more variable for finding out square root of a number. we have a skip function. So I'll declare one more variable called var_c, which is 4, because you get 2 basically when you apply square root to this var_c. I'm running both together, so you get var_c added here 4, and you get the square root of the same number as 2. And last but not the least, we have ABS to find absolute of a number. What this means, let's see that in action so that you better understand without me blurting out too much. So ABS of minus 1.6 becomes 1.6 because it's absolute, and on the number line there are no signs on the absolute, so 1.6. There are two more functions that we need to discuss. One is rounding off on either sides. We have floor to find the least possible nearby number on the left side of the number line. Let's see here what that means. Floor of 1.6 becomes, let's see what floor 1.6 gets us. Yes, so the 6 basically goes and travels towards the left side of the number line, which is 1.5, 1.4, 1.3, 1.2, 1.1 and 1. 1 is the nearest integer that you have to the left side of the number line. Similarly, we have something called as ceiling, which returns the integer closest to the right side of the number line, which is a bit higher. Finds the highest possible nearby number on the right side of the number line. It's called ceiling. The function is called ceiling. So let's try that out. It becomes 2. It must return 2. Otherwise, I'm gonna quit this and I'm gonna do something else. Yes, it is returning 2. So this is right, and we have covered almost 6 functions, I suppose. Yes, max. We have seen max returns a maximum of the integers or variables whichever we give to the function, pass to the function, and minimum gives out the minimum number that is passed on to the function, and square root basically returns a square root of a number. ABS absolute, and floor returns the left side closest integer, least possible integer, and ceiling returns the highest possible integer, right side of the number line. So that's it for the math functions and operators, and we need to discuss some rules for declaring the variables. So these are few basic rules which kind of followed in every language, which are kind of followed in every language that we know. The first rule is a variable name cannot start with a number. So let's see if this works. It doesn't. It's already thrown an error here because the numbers cannot be used. The first rule is that you cannot start a variable name with a number or a special symbol or special character which includes space. What this means, let's see that in action as well. So I'll basically var k equal to 7. It's already thrown an error here because you cannot start with the space. Even though I change the assignment operator, it still doesn't work. And also you cannot use any special symbols like the dollar symbol here. I don't know if it works. Oh, it actually works. No, it doesn't. Okay, so you cannot do any of these things. You cannot start a variable name with a number. You cannot use special characters such as space and dollar and whatever they are, but you can, there's a exception that you can use a dot. can use this and this works. Let's run this and see. I cannot see here. I don't know why that is, but yes, let's call this and see. Okay, I don't know for what reason that it has did this, but yes, so you can do this, but that is not allowed. And also you can declare a variable using starting its name with an underscore, and that works. Oh, even that doesn't work. Okay. Okay, so you cannot start with an underscore because that is also a special character supposedly. So and one important thing to remember is that you cannot use a boolean or a flag, especially for storing variables. So you cannot use this as a variable, I guess. I think because these are reserved keywords which are assigned a specific meaning and function inside of R by R itself inside R packages. So you cannot take these and use as a variable. So you cannot write this as well. I'll mention that as well. You cannot use a reserved keyword which has been assigned certain function and value to it by R itself inside R libraries. Also, you cannot do this in most of the programming languages. I don't know if a programming language that really exists which allows this, because then you cannot differentiate what the user wants you to do and what the libraries intend you to do. So that's the last rule. So I think it's enough for this video, which is what discussion of variables, data types, and math functions and operators. So let's cover loops, if else statements, and other concepts which are still fundamental before moving on to vectors, matrices, and other complex concepts introduced in R. So that's it for this video. If you like this video, please share, like, and subscribe so that you give me more engagement and I can help out more people in my journey towards learning R. Thank you so much. You've been a great audience. Thank you, folks.